What if I told you millions of people right now are feeling vivid sensations, tingling, warmth, sometimes excruciating pain in arms and legs that simply aren't there? Their brains are absolutely convinced these limbs still exist. Welcome to one of neuroscience's most fascinating mysteries. Welcome to the Weird Mind, where we explore the strange side of human psychology. Important reminder: today's content is educational and shouldn't replace professional medical advice if you're experiencing phantom sensations or chronic pain. Today we're exploring phantom limb syndrome, a phenomenon affecting the vast majority of amputees that reveals incredible truths about how our brains create our sense of self. We'll discover the body map hidden in your skull, groundbreaking 2025 research challenging everything we thought we knew, and revolutionary treatments using mirrors and virtual reality. Phantom limb syndrome is the sensation of a body part that's no longer present after amputation. And here's what's remarkable: it's incredibly common. Research published in the European Journal of Pain found that up to 82% of amputees develop phantom limb pain within 1 year, with lifetime prevalence reaching 76% to 87%. These aren't rare cases. This is the norm. The sensations take strange forms. Some patients describe their phantom frozen in painful positions, fists clenched so tight they feel non-existent fingernails digging into phantom palms. Others experience telescoping, affecting approximately 25% of amputees, where the phantom shrinks until a hand feels attached directly to the shoulder. French surgeon Ambroise Paré first documented this phenomenon in the 16th century, but it was Silas Weir Mitchell who coined the term phantom in 1871 while treating Civil War soldiers. Scientists have puzzled over this ever since. How does the brain create such vivid sensations in body parts that don't exist? To understand phantom limbs, you need to know about something remarkable: the homunculus. This little man is a map of your entire body laid across your somatosensory cortex, with different regions corresponding to different body parts. The region corresponding to the hand and fingers, for example, lies next to the area representing lips, nose, and eyes. Here's the strange part: this map is wildly distorted. Your hands, lips, and face take up enormous territory, not because they're large, but because they're richly innervated with nerve endings. For decades, the commonly accepted view among neuroscientists has been that following amputation, neighboring regions rearrange and essentially take over the area previously assigned to the missing limb. This explained why some amputees feel phantom sensations when their face is touched. But here's where neuroscience just got a major update. In a first-of-its-kind study, researchers from NIH and University College London found that the brain's control center for a lost appendage can persist long after surgical amputation, standing in stark contrast to long-standing theories about the brain's ability to reorganize itself. The team ran MRI scans on 3 participants in the months prior to a planned amputation, and then up to 5 years after. The findings challenged decades of textbook neuroscience. We observed stable cortical representations of both hand and lips in primary sensory motor regions. Amputation does not trigger large-scale cortical reorganization. The analysis revealed that the brain's representation of the body was consistent after the arm was amputated. Even 5 years after surgery, the cortical map of the missing hand was still activated in the same way as before amputation. This study is a powerful reminder that even after limb loss, the brain holds onto the body, almost like it's waiting to reconnect in some new way, said lead author Hunter Schoen. The hand map retained such precision that a machine learning decoder trained on pre-amputation finger movements reliably decoded phantom finger movements years later. If you're fascinated by how the brain creates our sense of self, subscribe now. We explore the weird world of neuroscience every Tuesday and Friday. Now here's where things get incredible: the treatments. Mirror therapy was unveiled by Ramachandran and Rogers Ramachandran in 1996. Using a simple mirror, patients see a reflection of their intact limb where the missing limb should be. Through this visual illusion, patients can move the phantom, unclenching it from painful positions. The technique addresses the mismatch between what the brain expects and what it perceives. The evidence remains mixed. Systematic reviews on mirror therapy's efficacy yield mixed results due to study limitations, such as small sample sizes and low levels of evidence. A 2021 meta-analysis found beneficial short-term effects within the first month, while a 2023 systematic review of placebo-controlled trials found no evidence of efficacy compared to placebo techniques. As researcher Hunter Schoen noted, these therapies continue to perform the same as placebos, which tells us that we're not actually targeting the mechanistic target of phantom limb pain. Many patients report meaningful relief, but the science suggests we may need to rethink our approach. Scientists are pushing further with virtual reality. In cutting-edge approaches, EMG electrodes on the residual limb detect electrical signals intended for the missing limb. AI algorithms translate these into real-time movements of a virtual limb. Patients control it as if it were their own biological limb. Lead author Schoen explained, "We trained a decoder on patients' brain activity before surgery and tested its ability to classify phantom finger movements years after amputation, and it worked remarkably well. If the brain retains a stable, high-resolution map of the missing hand, then future neurotechnology can exploit these enduring representations to enable more naturalistic control of prosthetic limbs." Phantom limb syndrome reveals something profound about consciousness. Our sense of having a body isn't created by the body, but by the brain. The authors propose that top-down motor signals and body schemas, rather than peripheral inputs, may be sufficient to maintain cortical representations. This reinforces the idea that the brain contains an internal model of the body that can endure, even in the absence of direct sensory input. The treatments emerging from this research, from simple mirrors to sophisticated VR, work not by fixing the body, but by updating the brain's expectations. Have you ever experienced phantom sensations, maybe still feeling a tooth after extraction, or sensing a ring on a finger when you've taken it off? Share your experiences in the comments, and if any unusual sensations concern you, please consult with healthcare professionals. What other mysteries hide in the gap between what our bodies are and what our brains believe them to be? Subscribe for more explorations into the weird, wonderful world of neuroscience.